In this quiet space of Dreamtime Science, we turn down the volume of the universe to hear its subtlest secrets. Let's explore the cosmos at the perfect pace for peaceful contemplation. You know what's fascinating? I've been thinking about how things around us keep moving, almost like they have a little secret force inside them that won't let them stop easily. There's something remarkable about momentum. It's like the universe's way of gently nudging objects to keep going, even when we're not pushing them. I can't wait to share why this simple idea is actually full of surprises. Your support through likes and subscriptions keeps this tranquil laboratory of knowledge glowing softly. Tell me in the comments, what scientific concept has always fascinated you? Let's prepare for tonight's journey. Find your most comfortable position, let tension float away from your body, and take 3 slow, peaceful breaths. There is a hush in the world just before something moves. An apple, poised on the edge of a branch, trembles in the autumn air. A bicycle, its wheels still as a pond at dawn, waits, balanced by invisible hands. Somewhere, a runner crouches at the starting line, every muscle taut, breath held, as if the world itself has paused to imagine the first step. In these moments, a kind of anticipation glimmers, an energy not yet spent, a secret promise of motion. And in the quiet between motion and stillness, our story tonight begins, with the curious, almost mythical notion of momentum. For millennia, humans have watched things move and wondered. What carries the stone from the catapult? What lets the ship glide on the sea? What makes the planets journey on their endless paths? Long before science gave names and equations to these mysteries, the act of starting and stopping was a matter of wonder and myth. Ancient storytellers, sitting by the flickering light of a fire, would spin tales of chariots pulled by gods, of arrows that flew with a will of their own, of boulders that tumbled eternally down haunted hillsides. Motion was magic, and the force that kept things moving seemed a thing alive, a spirit or a curse, never understood, only respected. The Greeks, ever the lovers of logic, gave these ideas their first careful shape. Aristotle taught that to keep something moving, you must keep pushing it, for he believed the natural state of earthly objects was rest. If a cart rolled, it was because oxen strained at the yoke. If an arrow flew, the bowstring's memory and the wind's kindness carried it aloft. When the force ceased, so too did the motion. This idea, so compelling, so intuitive, clung to human thought for centuries. It felt true, like the way our feet must press against the earth to walk, or the way a stone thrown eventually falls silent. But as centuries turned and the world's questions deepened, cracks appeared in this simple tapestry. Sailors saw ships glide for miles after the wind fell still. Children spun tops that twirled long after fingers left the string. The sky, too, was a stage for puzzles. Comets streaked across the heavens, planets wandered in stately procession, all without visible hands to guide them. Slowly, a new idea took root, a suspicion that something lingered inside moving things, something that did not require constant tending. It was a seed of doubt that would, in time, blossom into one of the most profound insights of physics. It was in the Renaissance, that age of rediscovery and daring, that the myth of momentum began its transformation. Galileo, peering through his new telescopic lenses and dropping balls from the Leaning Tower of Pisa, saw that objects, if freed from the tyranny of resistance, would keep moving. It was not the natural order for motion to die, but for it to persist, unless something, friction, air, a wall, robbed it of its secret cargo. Where Aristotle saw rest, Galileo saw endurance, and in his experiments the first true whispers of momentum as we know it today emerged. Yet the word itself would slip into the lexicon only later. Momentum, from the Latin movimentum, meaning movement or motion, at first seemed almost interchangeable with speed. But as thinkers like Descartes and Newton took up the challenge, momentum was given a sharper, more mathematical edge. It became, in their hands, not just motion, but motion with substance, something that could be measured, compared, even conserved. Newton, in his Principia Mathematica, wrote of quantity of motion, a product of an object's mass and its velocity. Here, then, was a new kind of magic, not the fickle favour of gods, but a rule of nature, elegant and unyielding. And yet the myths never truly vanished. The word momentum slipped from the halls of academia into the bustling streets and the dreams of poets. It became a metaphor for progress, for hope, for the unstoppable rush of history. Newspapers would speak of a political movement gathering momentum, as though ideas themselves could be swept along by unseen currents. Athletes, surging to victory, were said to have the momentum, as if triumph were a kind of wind at their backs. In these phrases, the ancient enchantment of motion lived on, a reminder that the science of movement still carried a trace of the old wonder. This popular image of momentum as a force, a fuel, a kind of mystical push, has shaped our collective imagination. We picture a rolling ball, impossible to stop, a train thundering down the tracks, a hero charging into battle with all the world behind him. Momentum, in these visions, is an aura, a charisma, a thing as real and yet as intangible as luck. We imagine it building, like a wave, and crashing, unstoppable, into the obstacles of life. But the reality, as the physicists patiently remind us, is both subtler and more astonishing. For momentum is not a force, not a push, not a mystical energy that builds and fades. It is rather a measure, a careful tally of two things: how much matter moves and how quickly it does so. To the scientist, momentum is the product of mass and velocity, a number with direction and magnitude, as precise and impartial as the ticking of a clock. An elephant lumbering at walking speed can have more momentum than a bullet whistling through the air, for mass is as important as speed. And a ballerina, leaping and spinning, carries her momentum in every limb, every turn, every graceful arc through the air. Yet the myths persist in part because momentum feels in our bones like something more than arithmetic. When we push a swing and feel it surge beneath our hands, when we watch a skater glide, arms wide, across a frozen lake, we sense that something has changed, something has been imparted. It is easy, natural even, to imagine that momentum is a reservoir, a storehouse, a thing that can be filled up and emptied. But in truth, momentum is not a thing, but a property, a description of how the universe keeps its ledgers balanced. The stories we tell in popular culture and everyday speech often blur these lines. In films we see cars racing through the night, impossibly accelerating, as if the only limit is the hero's will. In comics, heroes leap from rooftops with momentum that seems to multiply with every bound. Even in sports, momentum is invoked as a spirit that can turn the tide, that can make a team invincible or doomed with no apparent cause. It is a word that has become unmoored from its origins, drifting freely between science and story. This confusion is not merely poetic. It shapes how we understand the world, how we teach our children, how we interpret the feats of athletes and the struggles of nations. We speak of momentum as though it can be gained or lost at will, as though it is a prize to be seized or a curse to be endured. But in physics, to gain momentum is not a matter of desire or destiny, but of force and time, of mass and velocity, of causes and effects, as clear and inexorable as the rising of the sun. Despite its frequent misrepresentation, the allure of momentum endures because, at its heart, it captures a truth about the universe. That motion carries with it a kind of memory, a persistence, a resistance to change. When a football soars across a field, it does not forget the boot that sent it flying. When a planet orbits a star, it remembers the primordial swirl of gas and dust from which it was born. Momentum is the universe's way of honoring the past, of insisting that motion, once begun, does not simply vanish without trace. In the hush before sleep, as you lie beneath the weight of gravity and the quiet tick of your heart, consider the myriad ways momentum shapes our days. The morning rush of commuters, the languid float of leaves on a river, the restless dance of molecules in the air, all are governed by this subtle, steadfast principle. It is the reason a bicycle, once moving, resists the urge to tip, the reason a satellite, hurled into the sky, circles the globe for years without pause, the reason a glacier, ancient and immense, creeps inexorably toward the sea. And yet, for all its rigor, momentum retains its air of mystery. It is invisible, untouchable, a ghost that inhabits every moving thing, yet never reveals itself except in consequence. You cannot hold a bucket of momentum, cannot bottle it or store it for a rainy day. You can only observe its effects, infer its presence, measure its passing, like the shadow of a bird across the grass. In popular culture, this elusiveness becomes a canvas for imagination. In the world of video games, a character might leap farther by building momentum, as if speed itself could be banked and spent like coins. In fiction, a hero's comeback is described as a shift in momentum, a turning of the tide, as if fate itself has weight and direction. Even in business, momentum is invoked to explain the rise and fall of fortunes, the swell of innovation, the collapse of empires. It is a word that has become a talisman, invoked to conjure the promise of success, the inevitability of change. There is an irony, perhaps, in the way this scientific principle has been woven into the fabric of fantasy and metaphor. The true magic of momentum lies not in its capacity to grant victory or doom, but in its constancy, its fidelity to the laws of nature. It does not favor the bold or the lucky. It is not swayed by hope or fear. It is impartial, relentless, a thread that ties together the smallest drop of rain and the mightiest avalanche. And yet to recognize the myths is not to banish the wonder. For the story of momentum is the story of how we, as thinking creatures, have grappled with the mysteries of our world. Every myth holds a kernel of truth, every metaphor a glimpse of something real. When we speak of momentum in our lives, in our struggles and triumphs, we are reaching for a language to express the feeling of being carried forward, of gathering speed, of being swept up in something larger than ourselves. It is a longing for connection, for meaning, for the sense that our actions echo through time. As you listen, eyes heavy, thoughts drifting, imagine the long arc of history, the slow unfolding of understanding, the way momentum has travelled from the fireside tales of ancient shepherds to the equations scribbled in moonlit observatories. See how the myths have shaped our perceptions, how the reality has outstripped even our wildest dreams. And know that in the gentle balance between myth and science, there is room for both wonder and wisdom. In the darkness, the world holds its breath. There is a moment before the first motion when anything seems possible. The myths whisper, the equations wait, and somewhere, just out of sight, the next chapter of Momentum's story is about to begin. Let us then wade further into the currents of momentum, where the surface simplicity of moving things gives way to hidden depths, and even the most familiar motion becomes a tapestry of subtle forces and elusive balances. The word momentum itself seems sturdy and resolute, evoking images of rolling boulders, the rush of a sprinter, or the sway of a pendulum. Yet beneath that apparent solidity, momentum is a concept both intricate and layered, a bridge between the palpable and the abstract, the visible and the underlying symmetry of nature. Imagine, if you will, a polished marble rolling across a smooth wooden table. With a gentle nudge, it glides forward, its speed a direct testament to the push you gave it. At first glance, momentum appears as nothing more than the product of mass and velocity, a straightforward multiplication, as if the two properties simply hold hands and march forward. But as the marble moves, subtle factors begin to emerge. The resistance of air, the almost imperceptible texture of the wood, the friction at the contact points, they all whisper their influence, gradually draining the marble's momentum, slowing its journey. Long before it reaches the table's edge, the marble's once brisk pace dwindles until it halts in silence, momentum seemingly vanished. Yet, in the broader sense, momentum never truly disappears. It simply transforms, dispersing into the world in forms not always immediately visible. The frictional heat raised in the wood, the faint vibration of the table's fibers, the minute turbulence stirred through the air. Each is a fragment of the marble's initial push, scattered and diffused. Momentum, then, is not merely a property held by a single object. It is a thread woven through the interactions between things. The marble's journey is not an isolated event, but a dialogue with its environment, a negotiation of forces and exchanges. But what precisely is momentum, and why does it possess such a powerful hold on the structure of the universe? In the language of physics, momentum is the conserved quantity associated with the uniformity of space, an idea whose roots reach deep into the symmetries of the cosmos. If the laws of physics are the same here as they are a meter to your left or a kilometer to the east, then momentum must be conserved. This insight, formalized by Emmy Noether in the early 20th century, reveals momentum's true nature. It is not simply a practical measure of motion, but an expression of the fundamental order of the world. As we peer closer, the forms of momentum multiply. The simple linear momentum of a moving object, mass times velocity, is only the beginning. Consider the spinning of a figure skater, arms outstretched, twirling gracefully on the ice. As she draws her arms inward, her rotation speeds up, even though no external force propels her. Here, a different form of momentum reigns, angular momentum, the measure of rotational motion. Like its linear cousin, angular momentum is conserved, provided no outside torques intervene. It is this conservation that allows celestial bodies to spin for eons, that governs the whirls of galaxies and the dance of electrons around a nucleus. The mathematics of angular momentum introduces new subtleties. It is a vector, yes, but not one aligned with the direction of motion. Rather, it points along the axis of rotation, perpendicular to the plane in which the object spins. Its calculation involves not just mass and velocity, but also the distance from the axis, the so-called moment of inertia. The farther mass is from the axis, the greater its contribution to the total angular momentum. This is why figure skaters spin faster when they tuck in their arms. By bringing their mass closer to the axis, they reduce their moment of inertia, and to conserve angular momentum, their rotational speed must increase. Yet angular momentum is not confined to spinning dancers or orbiting planets. In the quantum world, it becomes stranger still. Electrons possess an intrinsic angular momentum, spin, not because they twirl like tiny tops, but because the mathematics of quantum mechanics demands it. This spin, quantized in discrete units, gives rise to magnetic properties and underpins the very structure of matter. The dance of momentum thus continues at scales both grand and minute, each step governed by rules that, while echoing those of the macroscopic world, bear their own quantum peculiarities. But even as momentum seems a universal currency, exchanged and conserved in all things, its very definition is bounded by our capacity to measure and describe. Consider for a moment the elusive boundary between the classical and quantum realms. In the world of marbles and skaters, momentum is a continuous quantity. We can imagine reducing it by the tiniest imaginable fraction and still have a meaningful value. In the quantum domain, however, this continuity dissolves. Momentum, like energy, comes in discrete packets, quanta. The act of measuring it changes the very system we observe, as if momentum were a secret, shy to reveal itself fully. Werner Heisenberg, in his revolutionary principle of uncertainty, showed that the more precisely we know an object's momentum, the less precisely we can know its position, and vice versa. This is not a limitation imposed by our instruments, but a fundamental property of nature. The universe, it seems, compels us to accept a certain fuzziness, a refusal to allow both the where and the how fast to become simultaneously sharp. Momentum, therefore, is not merely a number to be assigned, but a shadowy presence, always partly veiled, always slipping beyond our grasp, just as we reach for clarity. The complexities of momentum extend further when we consider systems of many interacting particles. In the solitude of a single marble, the rules are clear and manageable, but in the teeming jostle of molecules in a gas, or the interwoven motions of stars in a galaxy, momentum becomes a collective property, a sum over multitudes. Collisions between particles exchange momentum in fleeting stochastic pulses, yet the total momentum of the system remains steadfastly conserved. The individual chaos of molecules gives rise to the serene regularity of pressure, temperature, and flow, a statistical order emerging from a ballet of random exchanges. Yet even this statistical order is not absolute. In the realm of relativity, the notion of momentum is reshaped by the fabric of space-time itself. As objects move at speeds approaching that of light, mass and energy entwine, and momentum acquires new facets. The familiar formula, mass times velocity, is replaced by a more intricate relationship, reflecting the deep unity between energy, mass, and motion. The momentum of a photon, massless yet forever in motion, is given not by mass, but by its energy divided by the speed of light. The universe, in its generosity, gives even light its due share of momentum, and light in turn can push, pull, and exert force, as in the gentle pressure of sunlight on a comet's tail. Here, too, momentum's conservation is bound to the broader symmetries of space-time. If the laws of physics hold equally for all observers, regardless of their speed or vantage point, then momentum must be conserved in every frame, woven into the very geometry of the cosmos. This deep connection between symmetry and conservation, so elegantly captured by Noether's theorem, is one of the crowning insights of modern physics, a reminder that the dance of momentum is not merely local, but cosmic, an invariant pulse through the shifting tapestry of the universe. But as with any profound idea, our understanding is circumscribed by the horizon of what we can measure, predict, or even imagine. In the heart of black holes, at the threshold where quantum mechanics and gravity collide, the fate of momentum is uncertain. Do the familiar rules still hold, or does momentum take on some new, unknowable form? In the seething foam at the Planck scale, where space-time itself trembles and fluctuates, does the very notion of conserved quantities begin to unravel? These are questions that haunt the frontier of physics, where our best theories stray in and falter, and momentum's dance becomes a mystery once more. Even in the worlds we think we know, momentum is a concept whose edges blur. In the frictionless idealizations of textbooks, momentum is perfectly conserved, each collision an exchange of equal and opposite quantities. But the real world is never so pristine. Surfaces catch and snag, air stirs and resists, energy slips away into heat and sound. The conservation of momentum holds only within the boundaries of an ideal system, isolated from the noisy embrace of the environment. In practice, we must account for every hidden factor, every whisper of loss, every subtle interaction. The purity of the principle remains, but its application is always a negotiation, a compromise with reality's unruly complexity. And yet, despite these limitations, the idea of momentum endures, robust, adaptable, and endlessly revealing. It is a tool of understanding, a lens through which the patterns of motion become clear. It binds the fate of billiard balls and planets, electrons and galaxies in a web of mutual influence and exchange. It allows us to predict, to design, to harness the forces of nature in machines, in vehicles, in the very act of throwing a ball or sending a spacecraft to the stars. But there are still shadows, still corners where momentum's meaning is uncertain, where our equations falter and our intuitions stumble. In the turbulence of storms, the swirls of fluids, the complex interactions of living systems, momentum is conserved in principle, yet the path from cause to effect becomes tangled and obscure. Patterns emerge, dissolve, and re-emerge, never quite repeating, never quite predictable. The dance of momentum in these regimes is a wild, improvisational ballet, governed by rules we only partly understand. So, as you drift into the gentle dark, let your mind wander through the many guises of momentum. Picture the hush of a falling leaf, its slow spiral downward guided by the balance of air and gravity, the thunderous impact of waves on a shore, momentum transferred from wind to water to stone. The silent, ceaseless exchange of photons in the heart of a sunbeam, light's momentum pressing outward against the weight of a star. In each case, the underlying principle is the same, yet the specifics are endlessly varied, shaped by context, scale, and the ever-present limitations of our knowledge. There is a kind of comfort in this blend of certainty and mystery, a sense that, while the universe is knowable in part, it always keeps some secrets in reserve. Momentum, as we have seen, is both a rule and a riddle, a foundation and a frontier. It connects the tangible world of everyday experience with the abstract realms of mathematics and symmetry, history and possibility, cause and effect. It is a measure of the past and a harbinger of the future, carried forward in every moving thing, yet always just beyond the reach of perfect understanding. In the next gentle turn of our journey, we will follow momentum as it flows from the simple to the complex, from the solitary particle to the intricate systems that make up the living world. We will see how the rules of momentum shape the patterns of growth, movement, and change. How, even amid the chaos of life, the ancient dance continues, subtle and unbroken. There, in the interplay of order and randomness, momentum reveals itself anew, inviting us to look deeper, to listen closer, and to wonder at the hidden harmonies that underlie all motion. Through the gentle hush of centuries, in echoing chambers of thought and curiosity, the question of movement, of what it is, why it persists, and how it changes, has beckoned the gaze of philosophers, inventors, and scientists. Momentum, a word so compact, yet it contains within it a universe of motion and interaction. As the torch of inquiry passed from hand to hand, the desire to measure, to grasp, and to manipulate this elusive property led to a parade of inventions, each subtler than the last, each carrying us further into the heart of nature's machinery. We stand tonight as silent observers, drifting back through time to early halls of learning, where scholars hunched over parchment and brass, attempting to catch the shadow of motion in their nets of reason. Imagine the stone corridors of ancient Alexandria, or the open courtyards of Athens, where the concept of momentum first began to crystallize. Not as a named quantity, but as a question. Why do objects keep moving once set in motion? The earliest minds, Aristotle among them, speculated that motion required a continuous push. Without the hand or wind, a stone would drop dead from the sky. Yet even in this era, seeds were sown. Tools, primitive yet profound, were all they had. The human eye, the outstretched hand, the measured pace of a stride. Still, these were enough to begin. It would take the slow turning of centuries, the patience of the medieval scholars, to refine these questions. In the cloisters of Paris, John Buridan dared to imagine a property he called impetus, a spirit of motion imparted to a body, sustaining it even as resistance gnawed away. He spoke of rolling balls and flying arrows, of the way a cart, once moving, resists the pull of the earth. His impetus is not our momentum, but it is its ancestor, born of close observation and a willingness to be puzzled. And with each passing generation, the tools became more refined. The hourglass replaced the sun's arc for measuring time. The lever and balance lent heft to the study of weight and force. But it was in the ferment of the 17th century, as the modern world dawned, that momentum, still unnamed as such, was finally caught in the web of mathematics and experiment. Galileo Galilei, peering down from the heights of Pisa, watched as balls of different weight tumbled toward the earth at the same rate. His inclined planes, simple but ingenious, allowed him to stretch the brief, violent moment of a falling object into a slow, graceful slide, one that could be measured, timed, dissected. He used water clocks, bowls with tiny holes, dripping at a steady pace, to measure the intervals. The tools were humble, but the insight profound. That motion, when left untroubled by outside forces, persists. Galileo's experiments were, in a sense, the first true tools of momentum. They were not devices in the sense of brass and glass, but rather carefully constructed arrangements designed to tease out nature's secrets. The inclined plane, the rolling sphere, the gently pouring water, these were the instruments by which the invisible became visible, by which the fleeting became fixed enough to study. Let us dwell for a moment with these early experimenters in the cool hush of a candle-lit chamber. A ball rests at the top of a long, shallow ramp, an inclined plane polished to reduce friction, though not eliminate it entirely. Galileo, or perhaps one of his assistants, releases the ball with a steady hand. Down it rolls, gathering speed. At set intervals along the ramp, small pegs are placed, each one knocked aside as the ball passes. The sound of each peg striking the ground is recorded, the timing noted by the slow drip of water from a vessel. The experiment is repeated, each time with the ramp set at a new angle, each time with a new ball. Patterns emerge, patterns that whisper of a constant, a law beneath the surface. What, then, is being measured? Not simply speed nor weight, but the product of both, the momentum, though the term is not yet coined. It is the recognition that a heavier ball moving at the same speed carries more oomph, more resistance to change than a lighter one, and a faster ball, even if light, can strike with force. These early tools, ramps, water clocks, wooden pegs, form the foundation of experimental physics, scaffolding upon which later generations would build their own inquiries. As the century turned, and the young Isaac Newton contemplated the world from the quiet of Woolsthorpe Manor, the tools of momentum grew sharper still. Newton's genius was not merely in observing, but in formalizing. He took the scattered insights of Galileo, Kepler, Descartes, and others, and wove them into a tapestry of laws. His second law of motion, force equals mass times acceleration, gave the first clear mathematical expression to the idea of momentum. It was now possible to predict, to calculate, to extend beyond what could be directly observed. But prediction required precision. The age of the clockmaker dawned. Pendulum clocks, with their steady swinging arms, offered a new yardstick for time. Air pumps and vacuum chambers allowed experimenters to strip away the interfering drag of the atmosphere, to watch as feather and lead, freed from the caress of air, fell side by side. The Atwood machine, devised by George Atwood in the late 18th century, became a staple of the physics laboratory. It consisted of two masses connected by a string running over a frictionless pulley. By carefully measuring the acceleration of the masses as they moved, Atwood could confirm Newton's predictions about momentum and force, all while controlling for friction and other confounding variables. The Atwood machine is a marvel of simplicity, a device that turns the abstract into the tangible. In these quiet workshops and academies, the language of momentum gradually took shape. The word itself entered the lexicon in the mid-17th century, drawn from the Latin movimentum, meaning movement. It was a name for a quantity that had always been present, but which now could be measured, predicted, and manipulated. The balance, the pendulum, the inclined plane, the Atwood machine. Each was a tool not only of measurement, but of revelation. Yet, the true flowering of experimental momentum would come with the advent of precision. The 19th century ushered in the age of the laboratory, where glass and steel, wire and mercury became the keys to nature's inner sanctum. Here, the collision became a focal point of study. How do two bodies, meeting in space, share their motion? What is preserved? What is lost? Apparatuses were devised to capture these fleeting interactions. The air track, a gleaming smooth rail along which gliders could move with minimal friction, allowed for the study of nearly perfect collisions. Photographic timers and later electronic sensors tracked the position and velocity of each glider with exquisite accuracy. By measuring the mass and speed of each before and after collisions, the conservation of momentum could be directly observed, tested, and confirmed. Consider for a moment the elegance of a collision experiment on an air track. A glider, its mass precisely known, sits at rest upon the rail. Another glider, set in motion by a gentle push, slides toward it. The two meet, perhaps with a soft click, if bumpers are attached, or with a sharp crack, if rigid ends are used. The aftermath is recorded. Do the gliders stick together or bounce apart? What is their speed now that the interaction is complete? By comparing the total momentum before and after, the sum of each glider's mass times its velocity, one can see, with the clarity of numbers, the inviolable law of conservation. Momentum before equals momentum after, provided no outside force has intruded. The tools grew ever subtler. The ballistic pendulum, for instance, was a staple of 19th century ballistics research. A projectile, perhaps a lead ball or a small cannon shot, is fired into a heavy suspended block of wood. The block swings upward, its arc betraying the momentum imparted by the projectile. By measuring the angle of swing and knowing the mass of both ball and block, experimenters could deduce the speed of the projectile at the moment of impact. This simple yet powerful device bridged the world of mechanics with that of practical application, the design of artillery, the measurement of explosive force, the understanding of impact. Tools of momentum were not limited to terrestrial laboratories. In the vastness of space, the principle found new life. The recoil of a cannon, the thrust of a rocket, the dance of planets around the sun, all became examples, all became laboratories in their own right. Astronomers measured the motions of comets and planets, deducing their mass and velocity, and thus their momentum, by the way they pulled on one another, by the way they bent light and disturbed orbits. The tools here were telescopes, spectroscopes, and later the radio dishes that swept the heavens for the subtle whispers of moving objects. As the 20th century unfurled, the scale of momentum's tools shrank, even as their precision grew. In the world of atoms and particles, momentum became a matter of quantum probabilities, measured not by stopwatches and scales, but by cloud chambers and particle accelerators. The tracks of subatomic particles, etched in vapor or projected onto phosphorescent screens, told stories of momentum transferred and transformed. The conservation law held firm, even as our understanding of what constituted mass and velocity became layered with the strangeness of quantum uncertainty. The bubble chamber, invented in the 1950s, is a perfect example of the modern tool of momentum. A vessel filled with superheated liquid, on the edge of boiling, awaits the passage of a charged particle. As the particle zips through, it leaves a trail of tiny bubbles, a visible record of its path. By photographing these trails, physicists can reconstruct the momenta of particles, even those invisible to the naked eye. Collisions within the chamber, between protons, electrons, or even stranger denizens of the subatomic zoo, become vivid experiments, each a test of the conservation of momentum on the smallest scales imaginable. And now, as we drift through laboratories of glass and silicon, where lasers measure the recoil of single atoms and computers simulate the collisions of galaxies, the lineage of tools stretches unbroken. From the rolling ball on Galileo's ramp to the jets of particles smashing together at near light speed in the Large Hadron Collider, all are bound by a shared purpose: to catch, to measure, to understand the silent passage of momentum through the universe. Yet, for all their precision and ingenuity, these tools are more than mere instruments. They are extensions of our curiosity, bridges between the world as it is and the world as we imagine it could be. Each experiment, each device, is a kind of conversation, one in which the universe answers, not always in words, but in the language of numbers, patterns, and persistent laws. But the story of momentum's tools is not one of triumph alone. It is also a tale of boundaries and questions yet unanswered. For every collision measured, every trajectory mapped, new mysteries emerge. How does momentum behave when the rules themselves seem to bend at the edge of black holes, in the birth of galaxies, or in the flicker of quantum fields? Our tools grow ever more refined, but the quest continues, always pressing outward, always seeking the next horizon. And so, as the night deepens and the silence of the laboratory settles around us, we find ourselves poised between past and future, with the tools of momentum arrayed before us, simple and complex, ancient and new. Their work is not yet finished, their questions not yet answered in full. The next chapter awaits, where momentum's secrets unfurl in realms as vast as the cosmos and as small as the dancing atoms of our own hands. There is a gentle hush that descends as we drift from the technical to the philosophical, as if the very fabric of the universe slows its pulse for a moment, inviting us to listen more deeply. Momentum, once charted in the cold clarity of equations and measured in the precision of laboratory apparatus, now reveals another face, a mask of poetry, intimacy, and mystery. In the quiet hours of the night, when the world outside stills and our thoughts turn inward, we find ourselves not merely observers of momentum, but participants in its endless dance. We are, each of us, swept along by currents seen and unseen, propelled by forces ancient and profound. Momentum, in its scientific essence, is straightforward enough, the product of mass and velocity, a conserved quantity, a vector tracing both direction and magnitude. It flows from Newton's simple laws. It arcs through the vastness of space. It sustains the whirling of galaxies and the fall of autumn leaves. But as we step back, as we gaze at the web of connections that tie momentum to all things, a deeper resonance emerges, one that cannot be captured by numbers alone. Consider for a moment the way momentum whispers of continuity. It is a measure of persistence, of motion carried through time and space, a silent promise that what is set in motion will remain so unless and until the world intervenes. There is something almost mythic in this idea. To move is to possess a kind of immortality, a memory written into the skein of reality itself. The ball that rolls, the comet that journeys, the dancer who spins, each is endowed with momentum, and each resists the call to stillness, as though obeying a secret imperative. In this, momentum mirrors our own longing to persist, to carry forward, to leave traces. Our lives, too, are marked by beginnings and the inexorable press of time, by choices that set us in motion and forces that shape our paths. We accumulate experiences, ideas, regrets, and hopes, the intangible mass of the self, and with every step, every action, we build the velocity of our becoming. It is no wonder that poets and philosophers have so often borrowed the language of motion and inertia, the journey, the turning point, the unstoppable force. We sense, perhaps instinctively, that the laws of physics echo the laws of the heart. Yet momentum is not only persistence, it is also change. For every object in motion there comes a time of collision, a meeting with another, a transfer of energy and impulse. The world is not a vacuum, and neither are our lives. The momentum we carry is shaped and reshaped by encounters, some gentle, some violent. In the microcosm, particles collide and recoil, their momenta redistributed in patterns both predictable and wild. In the macrocosm, we too meet others, and those meetings alter our trajectories in ways we cannot always foresee. Reflect on the grace of conservation. In every interaction, the total momentum remains, though its form may shift. There is a kind of consolation in this, that nothing is truly lost, only transformed. The energy of a falling apple is not destroyed when it strikes the ground. It is shared with the earth, with the air, with the atoms that tremble in the aftermath. So too with us. The impacts of our lives, our kindness, our anger, our love, ripple outward, their effects dispersed but not erased. We are, in a sense, immortal in the momentum we impart to the world. The poetry of momentum is written not just in the grand, but in the everyday. Each breath you take, each gentle turn in bed as you drift towards sleep, is a negotiation with momentum. Muscles contract, mass shifts, forces balance and counterbalance in a quiet ballet. Even your thoughts, fleeting as they may seem, have a kind of momentum, a flow shaped by the chemistry of neurons, the architecture of synaptic paths. The mind itself, perhaps, is a river of momentum, memories and intentions cascading, branching and merging. In the wider cosmos, the implications are more profound still. Momentum is the guardian of symmetry, the silent law that undergirds the consistency of physics across the universe. Thanks to the insights of Emmy Noether, we know that the conservation of momentum arises from the uniformity of space. That is, the laws of nature do not change from one place to another. There is an exquisite beauty in this, that the motion of a planet 1 billion light-years away obeys the same rules as the stone you skip across a pond. The universe, in its vastness, is stitched together by momentum, a thread of continuity binding all places and all times, but even as momentum confers order, it harbours mystery. Why, at the most fundamental level, should momentum be conserved? Why should space be uniform? Why should the laws of physics possess this unyielding symmetry? These are questions that slip from the grasp of calculation and enter the realm of wonder. We can describe the rules, but their ultimate origins elude us. It is as if the universe contains, at its core, a secret, an agreement, ancient and silent, that motion shall persist, that change shall ripple outward, that balance shall be maintained. This symmetry is not mere abstraction. It is the reason why rockets can sail through the void, why a ballet dancer can spin with arms tucked tight, why the earth continues its ceaseless orbit about the sun. It is the reason that every act of motion, every push and pull, is echoed by a counterbalance elsewhere. The universe is, in its bones, a place of reciprocity, a place where nothing moves alone, where every impulse is answered by another. And yet, momentum is more than just a rule. It is a language. It speaks to us in the quiet persistence of waves, in the rolling swell of the ocean, in the hush of wind through grass. It is there in the measured thud of a heart, in the rise and fall of breath, in the slow, patient turning of the seasons. We are, each of us, in conversation with momentum, whether we notice it or not. The body remembers the rhythm of walking, the gentle sway of standing upright, the arc of a reaching hand. These are the hymns of momentum, a lullaby sung by muscle and bone, by earth and air. In art and literature, the motif of momentum recurs, a symbol of fate and inevitability, of progress and decline. The rolling stone, the winding river, the journey without end. These images speak to the way momentum shapes not just the physical world, but the stories we tell about ourselves. There is a sense, sometimes, that to be alive is to be caught up in a great current, to be propelled forward by forces we only dimly understand. We paddle, we steer, we strive, but always there is a deeper motion, a current that carries us onward. And what of the mysteries that momentum leaves unsolved? In the quantum realm, momentum is quantized, bound by the uncertainty principle. We cannot know both the position and momentum of a particle with perfect precision. There is always a veil, a shimmer of ambiguity. Here, momentum becomes a question, a probability, a whisper in the darkness. The classical certainty gives way to quantum possibility, and the poetry deepens. It is as if the universe in its smallest parts insists on surprise, on freedom, on the refusal to be fully pinned down. This uncertainty is not a flaw, but a feature, a necessary ingredient in the recipe of reality. It is what allows for change, for creativity, for the unexpected. In the interplay of certainty and uncertainty, the world finds its richness, its capacity for novelty and evolution. Momentum, once thought to be the hallmark of predictability, is also the harbinger of chance. There is something profoundly human in this duality. We too live lives poised between certainty and possibility, between the momentum we know and the futures we can only imagine. Our histories propel us, our dreams reorient us, our choices nudge us into new orbits. At every moment we are both determined and free, shaped by what has come before, yet open to what might yet be. The poetry of momentum is, in this sense, the poetry of living. It is worth pausing, in the stillness of night, to consider the interconnectedness that momentum reveals. The astronaut gliding through the void, the raindrop tumbling from a leaf, the child chasing a rolling ball. Each is bound by the same invisible threads. The push we give is never truly lost. It travels, transforms, and returns, sometimes in ways we cannot foresee. The energy of a footstep travels into the earth. The impact of a falling star echoes in the trembling of atoms. There is no true isolation, only a web of exchanges, a tapestry of momentum woven through all things. This interconnectedness suggests a kind of humility, a recognition that we are not solitary actors, but nodes in a network, participants in a cosmic relay. Our actions, large and small, reverberate outward, their momentum carried by winds and waves, by laughter and sorrow. To live with awareness of momentum is to live with awareness of consequence, of legacy, of the unseen threads that tie us to others and to the world. Yet for all its universality, momentum retains a hint of magic. It is easy, in the glare of daylight, to forget the strangeness that underlies the familiar. We take for granted the way a thrown ball arcs through the air, the way a door swings open, the way our bodies move from place to place. But beneath these everyday miracles lies a principle as deep as any in nature, a principle that speaks of unity, of endurance, of the power of motion to reshape reality. There is a temptation, perhaps, to seek final answers, to hope that, by understanding momentum, we might unlock the secrets of the universe. But momentum, like all the great themes of science, resists closure. It is both explanation and enigma, both clarity and shadow. The more we learn, the more we sense the vastness that remains unexplored. The poetry of momentum lies not in its resolution, but in its perpetual unfolding. As you listen, as you drift towards sleep, You may feel the gentle tug of your own momentum, the way your thoughts glide from one to the next, the way your breath rises and falls. You too are part of the story, an eddy in the river, a note in the symphony, a fleeting spark in the grand procession of matter and energy. Wherever you go, whatever you do, you carry with you the memory of motion, the echo of all that has come before. The world outside may be quiet now, but momentum never rests. It is there in the orbit of the moon, in the tidal pull of distant stars, in the slow, patient drift of continents. It is there in the laughter of children and the hush of old age, in the beginnings and endings that mark a life. The poetry of momentum is the poetry of existence itself, a song that began long before us and will continue long after, writ large in the movement of galaxies and small in the flutter of a moth's wing. And so, as night deepens and dreams gather at the edges of waking, let your thoughts linger on the mysteries yet to be revealed. Momentum calls us onward, through the darkness and into the unknown, carrying us on currents vast and subtle. There is always another turn, another meeting, another possibility, always another verse in the poem waiting to be sung. As our journey through the gentle currents of momentum drifts to a close, we watch like stardust as objects keep moving, their stories trailing softly like a comet tail fading into the hush of space. May this quiet wonder settle peacefully in your thoughts, inviting you to return for more Dreamtime tales, where the universe whispers its timeless mysteries.